Hi guys, here with your maths for today. So we're going to look at comparing and ordering fractions today. And we're going to be focusing on fractions that are less than 1. So we're going to have fractions rather than mixed number. So recap of what we already know. Pause the video here to have a go at these. Okay, so equivalent fractions, we need to look at the denominators that we've got. And we know that 20 is 4 times larger than 5. So the rule is here, we've multiplied by 4. So what we've done to the denominator, we now need to do the same to the numerator. So 2 times 4 will give us 8. Question 2, write the first 7 multiples of 7. It's just our 7 times table, isn't it? So it's a sequence as well. Each time we add 7. So we've got 7, 14, 21, 28, 35, 42, 49. Question 3, write the first 7 multiples of 4. Again, our sequence, we're adding 4 each time, 4, 8, 12, 16, 20, 24, and 28. With those sequences written out, we can answer question 4. What is the lowest common multiple of 4 and 7? So we'll look, we've got 28 here and 28 here. There is another way of doing this as well to give us 28. We can just multiply 4 and 7 together. It doesn't always give us the lowest common multiple of a number, but in this occasion it does work. So moving forwards, write greater than, less than, or equal to compare the fractions. So we've got 3/10 and 7/10. The denominators are the same, the numerators are different. So our first fraction, we can draw it out on a bar. We've got 3/10. Our second fraction is 7/10. And we can see from the 2 bars here that 7/10 comes further up than 3/10. So in this instance, 3/10 is less than 7/10. So 3/10 is smaller than 7/10. The other way around, 7/10 is greater than 3/10. Whichever way round you look at it, 3/10 will always be the smaller fraction in this instance. So we can start thinking about what we can apply as a general rule when we're things to help us. So when the denominators are the same, the something the numerator, the something the fraction. What do we think it could be? Well, we could either say when the denominators are the same, the greater the numerator, the greater the fraction. You can also say the inverse of this as well, the opposite. When the denominators are the same, the smaller the numerator, the smaller the fraction. We can see that from our example on the screen now. 3/10 and 7/10. The denominators are the same. The numerator is smaller, so that is the smaller fraction. So, write greater than, less than, or equal to compare these fractions. So when the denominators are the same, we know this. We have this. The smaller the numerator, the smaller the fraction. Here, though, 2/5 and 7/15. We don't have the same denominators. So we need to make them the same. We need to use our finding an equivalent fraction. So multiples of 5, 5, 10, 15. So our third term in this one is 15. 2/5 is equal to, or the equivalent to, how many 15s? So again, I need to look at what I need to do to the 5 to make it to 15. And I'm multiplying it by 3. So we need to remember what I've done to the denominator. I'm going to do the same to the numerator. So 2 multiplied by 3 will be 6. And now I know this, I can compare my fractions. I've made them equal denominators and I can compare them. So 6/15 is less than 7/15. So the rule we had when the denominators are the same, the greater the numerator, the greater the fraction, still applies. What we need to think about is how to make our fractions equivalent so we have the denominators the same. So our answer here, 2/5 is less than 7/15. Have a go at these ones. So remember, you're going to need to convert or make some fractions equivalent when we do this. Look at the relationship between the denominators. That will help you out here. Right, greater than, less than, or equal to, and compare the fractions. Pause here to do this. How did we get on? Our first one, 1/6 and 5/18. So 1/6 is equivalent to 3/18. We know this because we've multiplied 6 by 3 to make 18. So what we do to the denominator, we need to do to the numerator. So 1/6 is less than 5/18. Looking at question 2, 3/5, we make it into 20/5. We have to multiply it by 5. And remembering again, what we do to the denominator, we must do to the numerator. Equivalent fraction of 3/5 is 15/25, which is greater than. So 12/25 is less than 3/5 or 15/25. Now the bottom one is a bit of a trick question. Our denominators and our numerators are both equal. So both of these are equal to 1. So if both sides of our thing are equal to 1, the symbol that goes in the middle will be equals. Now you could have spent time and worked out that 9 times 4 is 36 and to get the denominators equal, and then done the same for the numerators. But we need to, there's one of the things to remember is so long as the denominator and numerator are equal, or they're the same, it will be equal to 1. So have a think here. I know that 4/7 is greater than 5/11 without having to draw a bar model or find a common denominator. How could this be true? Pause here. We can work this out by looking at the relationship between our numerator and our denominator. So we have 4/7, we have 5/11, and we can work out which one is greater without having to draw a bar model. So how do we go about doing it? I can roughly divide. 7 divided by 2 is 3.5. So I know it's greater than half because I know on a number line, 3.5 is less than 4. So 4/7 is greater than 1/2. If I look at 5/11, 11 divided by 2 is 5.5. 5/11 is less than halfway. So some of them we don't need to necessarily exchange or make them equivalent to each other. We can just use some number facts that we know. So we know that 4 is more than halfway through 7, and we know that 5 is less than halfway through 11. We can use that knowledge to put our fractions in order as well. So I know that 4/7 is greater than 1/2 and 5/11 is less than 1/2. So 4/7 has to be greater. How about this one? Have a think. Think about what we've just talked about. Pause here to have a go. Okay, how did we get on with that one? 8/14 and 10/22. So we know half of 14 is 7. 8 is greater than 7, so we've got more than half here. I know half of 22 is 11, and I know that 10 is less than 11. So I can say without having to draw anything out, do lots of complicated multiplication, work out how to make 14 and 22 equivalent to each other. I can do it just by dividing by 2. So 8/14 is greater than 10/22. So we've got 4/9 here, 4/5. And we've got 2/3 and 2/7. So here we've got our numerators as the same. So we can draw them out. So I've got 4/9. I've got my bar there split into 9, sorry. I've coloured in 4. I've got my 5ths. Got my bar, same size bar. Remember, we're comparing, the whole will be the same. All we're talking about with our denominators is what the bar's been cut into. So we've got 4/5. We can see visually that there is more fifths, or sorry, there is more on the 5ths bar than there is on the 9ths bar. So 4/5 is greater than. And we've got the same 2/3 and 2/7. So again, I'm going to split my bar into thirds, colour 2 of those in, split my bar into 7ths, and I'm going to colour 2 of those in. Kind of given away the answer a little bit for this one. What's the same and what's different? What do you notice? Because I haven't given you the answers for that, but I have talked about one of the features that's the same and what's different. I wonder if you were fully paying attention. Pause the video here, see if you can answer these. How did we get on? So 4/9 is less than 4/5, and 2/3 is greater than 2/7. So what's the same? Our numerators, nearly caught myself out there. Our numerators are the same. Our denominators are different. So we know when the numerators are the same, the greater the denominator, what do you think is going to finish the sentence? You've got a 50-50 here. You've got a half a chance of getting it right. Is it going to be greater or is it going to be smaller? What do you think? So when the numerators are the same, the greater the denominator, the smaller the fraction. It's because our whole's been made into more pieces. So if we look at our top example, it says 4/5 and 4/9. Well, you might think there's 9 pieces and 4 of those, it means I get more. It doesn't. So you've got to think of the total number of pieces that it's cut into. So there's more. So the smaller the denominator, the greater the fraction. And the inverse is true. So the greater the denominator, the smaller the fraction. So it's worth keeping an eye on that and remembering that the number of pieces that something's broken into has a big effect on how much each piece is worth. So when the numerators are the same, the greater the denominator, the smaller the fraction. And when the numerators are the same, the smaller the denominator, the greater the fraction. So using that as a rule, we've got 1/3 and 1/100th. 1/3 is greater than 1/100th because what we've got is split into 3 pieces, and having one of those 3 pieces has a lot more value than if you've cut something into 100 pieces and you've got one of those 100 pieces. So, right, greater than, less than, or equal to. Compare the fractions here. So when the numerators are the same, the greater the denominator, the smaller the fraction. Well, here, how can we make our numerators the same? I need to multiply by 2. So if I multiply my numerator and my denominator here by 2, they become, I have equal numerators. And I can use my rule. When the numerators are the same, the greater the denominator, the smaller the fraction. So 3/7 is 6/14. So I've got my numerators the same. My denominator is greater, so my fraction is smaller. So in this instance, 3/7 is less than 6/11. So with the rule that's on screen now, when the numerators are the same, the greater the denominator, the smaller the fraction. So instead of making our denominators the same, we're going to make our numerators the same. Pause now to have a go at these and remember the rule. How did we get on? We'll look at our first one, 3/10 and 12/37. So I can make my numerators equal by multiplying by 4. So 3/10 becomes 12/40. 40 is greater than 37, so it's a smaller fraction. So 12/37 is greater than 3/10. Looking at 20/62s, I can do the inverse here. So instead of multiplying 10 by 2, I can divide 20 by 2. So I can divide by 2. Be careful using it this way round. It only works if you've got even numerators and denominators. So it might be that you need to multiply. So if we had 61 at the bottom of this, I couldn't turn it into a fraction where the numerator is the same, because I'd have a decimal number at the bottom, and that doesn't work for fractions. As it is, this example, it will happily divide by 2. So 20 divided by 2 will get me 10. 62 divided by 2 will get me 31. So again, 31 is greater than 27. So in this instance, that's the smaller fraction. So 10/27 is greater than 20/62s. Got 3/8 and 1/5. So this time I'm going to multiply by 3 to make my numerators the same. 3 times 1 makes 3. 5 times 3 makes 15. So this is equivalent to 3/15. So again, using our rule, the greater the denominator, the smaller the fraction. 3/8 is greater than 3/15. Now it's your turn. Pause the video here to complete these questions. Okay, how did we get on? So the answer's coming up now. Using the bar models, we can colour in the relevant parts. So 7/8 is greater than 3/4. 9/12 is equal to 3/4. 7/12 is less than 2/3. Question 2, we're practicing the skills. So A, 1/5 is greater than 4/15, and so on. So check you've got your operations in the right order. Sorting the fractions into circles. So we're looking at dividing to turn them into thirds, whether they're greater than a third, equal to a third, or less than a third. So greater than 1/3, 2/3, it certainly is. 1/2, we know that is 5/12. Well, we know 1/3 of 12 is 4. 5 is bigger than that. Equal to a third, 2/6, 1/3 of, so 3 times 2 makes 6. 4 times 3 makes 12, so it's 4/12. 5 and 15, 5 times 3 makes 15. Also 15 divided by 3, divided by 5 makes 3, so it's equal to a third. Less than a third, we've got 1/6, 2/9, and 4/15. So we know 1/3 of 6 is 2. 1 is less than 2. 1/3 of 9 is 3. 2 is less than. We've got those there. So looking at question 4, I thought I'd go through this with you. So we need something that a number of fifths is less than 5/15. So we can have 1/5. So if I multiply this to make my numerators equal, or even if I do it to make my denominators equal. So 3 times 5 makes 15. 3 times 1 makes 3. This is correct. Here, 6 times 2. So our rule here is we're multiplying by 2. So I need something on the top here that I can multiply by 2 that will be less than 5. So you could have 2. 1 will also work. We've got the same again here, so we've got 12ths. So I need something here. So I'd need to divide, so I need to work backwards this time. So we're going this way. So if I multiply this, I need something less than 10. So I could have 9 or 8, 7, 6, 5, 4, 3, 2, or even 1. So this one here. So we've doubled this, we've multiplied by 2. So I need something that when I multiply it by 2, it's less than 5. Well, we can have 2, which will give me 4. 1 is also an acceptable answer here as well. This one here. So we need something that's 5 somethings is greater than. Now we could have a top heavy fraction or an improper fraction. We could have 5 over 4. We could also have, as another option, 5/5, which would be equivalent to 1. 5/6, again, we could be really simple. 5/5 works really nicely there. 6/9. So we've multiplied. Nope, we haven't. Ignore me. We can use the same trick. We can make this equivalent to 1, or we can make it an improper fraction. We could have 5 over 4. We can, there's lots of ways of making this one correct. This one here, 5/5 works really nicely. If you've put 5/6, that would actually make these equal, so it wouldn't work. 23/24, again, I'm going to go with 5/5. So we can, by looking at our fractions, we can work out what we need to do with them in order to make these statements correct. The last few, you will probably have some different answers that work just as well. So just make sure that the statements are correct. Well done today. As always, stay safe. We'll see you soon.